Hello everyone, my name is Dian Afrianti Sembiring and welcome to another episode of my podcast. Today we are going to discuss a very important topic in heavy transport engineering. Why can the same load be unsafe in one position and safe in another position on an SPMT? Okay, let's start. When engineers transport massive equipment such as pressure vessels, reactor, columns, modules using an SPMT, one of the most important factors is not the weight itself. So the most the most important factor is not the weight itself. It is the location of the center of gravity, or we call it COG. So this is the most important. Where is our COG location? Yeah. Many people assume as long as the transporter has enough capacity, everything is fine. Unfortunately, that's not always true. A transport can fail even when the SPMT has more than enough capacity. Why? Because the stability is not determined by weight alone. Okay? I repeat again. I repeat again. Because the stability is not determined by weight alone. It is determined by where that weight is positioned. Yeah. The wrong configuration. Now, we talk about the wrong configuration. Yeah. Let's look at the first example through the video that I shared with you before. In this configuration, the center of gravity is not aligned. First video, in this configuration, the center of gravity is not aligned with the center line of SPMT. So we talk about the first video. Yeah. In this configuration, the, the center of gravity is not aligned. Yeah. With the center line of SPMT. Yeah. The load is offset to one side. Yeah. So the load is offset to one side. As the result, some axle lines carry more load. Okay. Some axle lines carry more load. The next is other axle lines carry less load. And then suspension, compression is become uneven. And the next is steering performance is affected. Yeah. So from the first video, we understand that the COG is not aligned with the center line of SPMT. And then the load is offset to one side. As the result, some axle lines carry more load, other axle lines carry less load, suspension compression become uneven, steering performance is affected. Yeah. The transporter is moving. Yeah. So at first glance, everything might appear acceptable. Yeah, at the first glance, everything may appear acceptable. The transporter is moving smoothly, nothing seems wrong. But the problem appears when the transporters encounters what? Yes, cross slopes, uneven ground, ramps, turning movement. At that moment, the overturning force increases and the safety margin begins to disappear. Yeah, we have to remember that. We have to remember that. The problems appears when the transporter encounters cross slopes, uneven ground, ramps, turning movement. Yeah, at that moment, the overturning force increase and the safety margin begins to disappear. Okay, so this is a very important message that I wanna give it to you. The correct configuration. Now we talk for the second video. Yeah. Now let's look at the second example. In this arrangement, the center of gravity is aligned with the center line of the SPMT. Yeah. So here, in this arrangement, the center of gravity is aligned with the center line of the SPMT. You can play back again the video so you can see. So the load is balanced. Yeah. The force travels directly through the center of the support area. Yeah. The force travels directly through the center of the support area. This creates several advantages. Yeah, number one, better load sharing between axle lines. Yeah, and then improve suspension performance. More stable, more stable steering. Lower risk of axle overload. Yeah. Lower risk of axle overload. And then greater resistance to rollover. Yeah. Greater resistance to rollover. Sorry. In other words, the transporter works the way it was designed to work. Yeah, this is the message that I give it to you from the first video and then the second video. And then now we talk about why does this matters? Why does this matters? Yeah, imagine you will transporting a 1,000-ton vessel. Yeah. This one, okay? If the load is perfectly centered, so the left side may carry 500 tons, okay? And then the right side might carry 500 tons. We said that this balance, yeah? But if the center of gravity shifts, so one side might carry 650 tons and The other side only carry 350 tons. The weight has not changed. Yeah, the total weight has not changed, but the risk has increased dramatically. This is why experienced transport engineers spend so much time calculating center of gravity and load distribution before a move begins. Yeah. So now let's talk about common causes for stability problems. Common causes of stability problems. Yeah. In the real project, instability is often caused by, we talk about instability here. Number one is incorrect load positioning. Next, wrong center of gravity calculation. Yeah. Next is asymmetrical support saddles. Yeah. And then unexpected internal equipment weight. Yeah. And then next is cross slope condition during transport. Okay. So in real project, instability is often caused by incorrect load positioning, wrong center of gravity calculation, asymmetrical support saddles, unexpected internal equipment weight, and cross slope condition during transport. A load that is stable in the yard may become unstable once it enters the transport route. You have to remember that. Yeah, that's why engineering verification is critical for this project. Yeah, for this project. So now let's talk about the golden rule of heavy transport. After more than 2 decades in lifting operation, I can summarize SPMT stability in one sentence. The vertical projection of the center of gravity must remain within the support polygon with an adequate safety margin under all transport conditions. Yeah. So remember this. Remember this. I will write down here. The vertical, yeah, projection, the vertical projection of the center of gravity must remain within the support polygon with an adequate safety margin under all transport conditions. Yeah. Not only when the transporter is standing still, but also during steering, braking, acceleration, slope crossing, uneven terrain, road transition. Because once the center of gravity moves outside the support area, the risk of rollover increases significantly. You have to remember that. Once the center of gravity moves outside the support area, the risk of rollover increases significantly. Yeah. So final touch for us in heavy transport engineer, success is not simply about moving a load from point A to point B. Success is moving that load safely. Yeah. And safety margin must be applied. Okay. Safety begins with understanding where the center of gravity is located. Yeah, because sometimes the difference between a successful transport and a catastrophic accident is only a few inches of center of gravity offset. So this is very important to understand about center of gravity, either for lifting operation and for the heavy transport. Because center of gravity is all about stability. I hope you understand for our topic today. Thank you for watching. My name is Dian Afrianti Sembiring, and this is my The Decision Room podcast. If you found this video valuable, don't forget to like, share, and subscribe. If you want to understand more about stability for heavy transport, you can write down in comment below, and then I will send you detailed information about when we will have class for stability for heavy transport. See you in the next episode.